Hello students, so in this lecture we will be discussing about different types of quantum dots. Now first we will start with a nanocrystal quantum dot. Now a nanocrystal is normally a crystal which has been derived from, which has been grounded from a microcrystal, and it has the dimension of few nanometers. Now, the difference between a nanocrystal and nanocrystal quantum dot, that means when you are talking about a quantum dot, so additionally, a quantum nanocrystal quantum dot should have the property that it should have the smaller band gap than the surrounding medium. And the advantage of having a quantum crystal nanocrystal band gap is the color is directly proportional to the dimension. By changing the dimension, you can have different colors. So the first example is of a cadmium selenide nanocrystal. Now, cadmium selenide formed, they are spherical. Usually, they remain in the spherical shape with a diameter 1 to 10 nanometers, and they are beneficial because they are advantageous. We have the very good properties of luminescence because the room temperature quantum yield and the photostability of these materials are high, and in addition of cadmium sulfide, they go even more than what is there for cadmium selenide. So this is one type of nanocrystal quantum dot. The second is your single electron transistor. Actually, this is where an aluminum island is being created. Aluminum and aluminum oxide island is created, and there are two metal contacts at the end made up of niobium. So this is the macrostructure from where you can see the formation of ACT has taken place. The sides are the niobium, and in the center you have this aluminum oxide uh, uh, region or island where only single electron transition can take place on matching of energies. Next is the silicon quantum dot. Silicon quantum dot are made by basically silicon clusters embedded in silicon matrix, and uh, they could be fabricated or made by ion implantation. So we have silicon ions being implanted on previously SiO2 substrate, and this ionic. So when the ions get trapped in the SiO2, we say that silicon SiO2 substrate is formed. The next is the lithographically made quantum dot. Now this is where we have layers of different materials. Like if this is a layer of gallium arsenide layer, and this is again the gallium arsenide layer, and in between all the different indium gallium arsenide is kept. So by rigorous grinding, we get a shape like this, where a quantum dot has been formed at the center with source and drain at the two sides, and they have a little bit higher diameter of 500 nanometer, and the thickness is about 50 nanometers. They are confined in a potential of 200 millielectron volt, and they have a controlled geometry and elevated contacts. Now coming to a field effect quantum dot. Field effect quantum dot is from the diagram you can see a field effect quantum dot has been made by modulating doping heterojunction. This is basically, so here is the quantum dot formed. So basically a uh, two-dimensional electron source is there, which leads to, and it is helpful in IR detectors, infrared detectors. And lastly, we have a self-assembled quantum dot. Self-assembled means it is formed during the epitaxial growth. Now we know that we have three types of epitaxial growth First one is Vandermeer, and the second one is island growth, and the third one is island, initially island, and the text is your initially layered, then island. So this SK growth falls into the third category. So initially, even if there are formation of films taking place, so after a certain point of time, the film formation will stop, and rather than island formation will start to take place. And so in the case of an island SK quantum dot, the defect density is in this range, and it can be basically two semiconductors side by side. So it can be indium arsenide on gallium arsenide or indium phosphide on gallium arsenide. And this SK growth, this is iron plus layer growth, and it comes in existence by use of these some of these techniques which out of which molecular permeability is the most coveted technique. So you are basically forming a quantum dot or a quantum dot on a quantum well. So that's it.